We're now going to dive into two features of the JavaScript engine that are important to understand: memory heap and the call stack. These are used throughout code execution. First, I'll describe each one of them, and then we'll see them in action to better understand how they are involved in code execution. Now, the memory heap, as the name indicates, has to do with memory allocation. Whenever you define a variable, object, function, anything like that in your code, there needs to be a place to store it. So like these variables here would be stored in the memory heap. Whenever a declaration is encountered, such as this, the value is placed in the memory heap, and then the location of that value is placed in the variable. Then whenever the code needs that value, or the function, or whatever is stored, it uses the memory location to look it up. Now, the memory heap has a limited amount of memory, so complex programs that have a lot of variables and nested objects can chew up that memory. The JavaScript engine tries to make more memory available by clearing out data from the program that it determines is no longer necessary. This process is called garbage collection. There are things you can do as a programmer to assist in garbage collection, and there are things you could do that could hinder it. We will look at this in more detail in the topic on garbage collection. But for now, let's talk about the call stack. Anytime we run code, the call stack is used. It is simply a place in memory that keeps track of the function executing and the functions that are going to be executed after that. So the order in which these commands are executed. Now each function is placed on top of the previous function. So the first function in is at the bottom of the call stack. And then as other functions are called, they're placed on top of it. So the call stack follows a first in, last out approach. Now, as soon as a function or command is completed, it is removed from the call stack. Now, as you can see from the diagram, there is only a single call stack depicted. The JavaScript engine only has one call stack to deal with commands that are executing. That is because JavaScript is single-threaded, a term you may have heard of. Now, a single thread means that the JavaScript engine can only execute one part of the program at a time. So the call stack deals with one command at a time. And as a result of this, JavaScript is synchronous. Commands can only be executed one at a time. You can probably see a possible problem with this. What if we invoke a function that requires a long time to run? How can we prevent that from blocking other code? For example, we want a user to be able to click on a button and not have to wait 2 seconds for some JavaScript to finish before it can respond to that button. Now, we'll dive into how this is handled and how the JavaScript engine deals with it when we talk about the event loop. And this is also why it's important to understand asynchronous JavaScript patterns in JavaScript. And that's one of the critical parts that we deal with in this course. Now, in our diagram, as you can see, we have some very simple code. Let's walk through it with the memory heap and the call stack. Illustrate how those are used in moving through the code. Basically, what we're doing is we're declaring two variables, A and B. Then we have a function declared, and then we invoke that function here. Inside of the function, we call console log. We call set timeout and pass in a function to set timeout. The time for that is 0 milliseconds. And then we call console log again. So let's move through this. First, we have the variable declarations. And so each one of those are going to be placed in the memory heap. There's one and a second. Now, there's no specific order in how they are placed in the heap. They just need a reference to where that value is located. Then we have our function, and that's going to need to be placed in the heap as well. And there we've added that to the memory heap. Now, if there were any variables declared inside of that function, those would need to be placed in there. Or if there are functions declared inside it, if there are other things inside that they need to go in the memory heap, that would need to happen. But now we encounter the call to hello world, to that function. We're invoking it. So the JavaScript engine grabs that code from its memory location, and then it's able to begin executing it using the call stack. So the hello world function is placed on the call stack. That indicates where we're at within the code execution. So right now we are inside of function hello world. And we come to the first command in there, and that is a call to console.log. So we are invoking console.log, and that gets placed on the call stack. Now we're able to complete that command. And so once that command is complete, it is removed from the call stack, and we're able to continue on. And we get to set timeout. And set timeout is added to the call stack. However, set timeout is something that is a part of the web API, as you can see over here. So JavaScript doesn't need to do anything with that. So basically it gets rid of it. It sends it to the browser and says, here, I've got a call to set timeout. Here's the information. You go ahead and take care of it. And then the JavaScript engine forgets about it at that point. The web API will set up a timer for that set timeout, and it will handle everything that needs to be handled with set timeout. But at this point, the JavaScript engine has simply forgotten about it. It's not worried about it anymore. It simply continues on to the next command, which is another call to console.log. And so that gets added to our call stack. We're able to take care of that right away. We send a message to the console, which happens to be world, and then that's removed from the call stack. And then at that point, we're at the end of the hello world function, and so that is removed from the call stack. Now you can see how the call stack could get built up with a number of things if we had functions called inside of other functions. And the more we have nested functions like that, the more things that are going to be added to the call stack. And we'll build up on that call stack. Because until a function returns, until it completes, it cannot be removed from the call stack. Now with this whole illustration, I left set timeout over there and said the JavaScript engine just forgot about it. Well, we're going to talk about that when we get to the topic on the event loop, because really it is the event loop and the message queue that deal with that deal with these web API items. So we'll discuss that in another topic. But before we move to the next topic, I want to address something we can encounter with a call stack. It's called stack overflow. And this is a condition you may have run into with your coding. This occurs when the call stack fills up because it can't remove commands and more keep getting added to it. I mentioned that nested functions could add a lot to the call stack. Well, it takes quite a bit in order for the call stack to fill up. But when it does fill up, it causes an error. Now, we can simulate this pretty easily with a recursive call. Now, recursion is simply when a function calls itself. And there are some situations where this is an advantageous pattern in JavaScript. But I want to show you the effects of what it does on the stack. So let's go ahead and set up a function that will illustrate this. This JavaScript file is attached to the HTML file. This one here that we were looking at previously. So I'm just going to put a function on it and call itself, and we're going to see what happens. So let me call it recursion. There's not necessary to call it that, but I'm going to do that because I'm going to be calling it. And then I'm going to set the number that is passed in equal to itself plus itself. Something simple like that. And then here is where the recursion happens. We invoke itself from inside. So think about what this is going to do to the call stack. We're going to call recursion. It's going to place recursion on the call stack. It's going to get down to this line, and recursion is going to be called again. But the function hasn't completed, so it's not removed from the call stack. Another invocation of that is added to the call stack. And so it keeps adding recursion to the call stack till it builds up to the point that it can't add any more. And that's where we get that stack overflow. So let me go ahead and invoke this. I'm going to pass in the number 1. We'll save that. Now, since I just have that attached to this HTML file, I'm just going to refresh that and see what happens. Let's open up the console and see what we have there. We have an error. Uncaught range error, maximum call stack size exceeded. So this is the error we would receive if we had a stack overflow. Maximum call stack size exceeded. That's what we're getting there. Now, this is a simple problem to solve. All we have to do is make sure that eventually the functions start completing, that they return, and then it can remove them from the call stack, eventually remove all of them from this call stack. Let's look at how that might be done. Let's say that if the number is greater than, and I'm just going to put a large number here. I have no idea how big it's going to be. But if it's greater than that, then I'm just going to log it to the console. I want to see how big the number is just for the fun of it. And then I'm going to return. See, here's where we're returning from this function. And so it will complete the function. We return here. It won't do this again. And it will complete that function that we're in. And so then it will unwind the call stack. Each of those functions will finally get to return because it will get to the end of the function. And so the fact that the last time we call this where num is greater than this, that forces a return, doesn't call another one. And so all of those others that are in the call stack get to complete as well. And so then we don't get that stack overflow. All right, let's look at that just one more time. So I'm going to refresh here. Oh, I want to, the number's not getting larger if I don't pass it back in when I call that function. So I want to make it sure it's getting larger. There we go. Now we get a very large number coming out, and we're no longer getting the stack overflow because it was able to return and then unwind all of those function calls that are in the stack. So that's what we're referring to when we're talking about stack overflow. All right, let's move on to the next topic.